First thing with this one, right, we flipped it over a little bit. 3 minus 2x, if we drew 3 minus 2x, that would normally look like this. Going through 3, right, this would be 3 on 2. Take it, flip it. Yeah? There's your graph. But in terms of zones, I'll leave this down here. Right? Your key point is now at 3 on 2. Less than 3 on 2, greater than 3. So that's it. Find where I'm 0 and then talk to the right, to the left and add it. When you are going to the left of 3 on 2, this thing here was the original graph before I did any flipping. Yeah? That was the original graph which had that name. Right? This is where people sometimes get confused when they're drawing a negative graph. That is the original guy before I flipped. When it was 3 on 2, easy, 1 is 0, check. And when I went beyond 3 on 2, my normal graph would have gone below the x-axis. I now flipped it, so that means y is the negative of what I was drawing in the first place. That's how you define your second equation. Stick a negative in front of what you should have been drawing if there were no bars. That equals 2x minus 3. And think about that. If that continued, it would come back here to negative 3. That makes sense. Yeah? The bit that I flip, I stick a negative in front of its name. Everyone's got that? It's on the video anyway. So, the next one, the ugly one. What is it? X minus 3. Okay. This is what I would be doing. Spotting the zones. Alright? This causes a problem when x is negative 1/2. Right? That's the beginning of the zone. This is 0 when x is 3. So I come along here and I mark 3. So they're my two zones. Okay? Both graphs are positive sort of thing, so you know you're expecting 2 v's if I split it. So, if x is less than negative 1/2, over here, right? What would have happened to these graphs? Am I dealing with the negatives or the positive versions? Way over here. Negatives. So I just go, y equals, I would have flipped the first one, and I would have flipped the second one. So I just wrote a negative in front of both names. That ends up being negative 3x, that's negative 1 plus 3, which is plus 2. Okay? Negative 3x plus 2. I'll worry about drawing that in a second. I work from left to right. In between negative 1/2 and 3, in the in-between zone, right? What am I dealing with? This would have been positive, correct? Yeah. And this one would have been negative. So stick a negative in front of its name. x1 plus 3 plus 4. So I've been nasty here, so you've now actually got another linear equation. We'll worry about drawing it in a second. And when x is bigger than 3, way out here, right, both are positives. So I just write the normal names. 2x plus 1, x minus 3, 3x minus 2. Normally, these end up being flips of each other. See, negative 3 plus 2, positive 3 minus 2. That's what will typically happen. Because you've gone plus plus, minus minus, but you're still putting the same things together. 3 graphs. Draw them. And you say, yeah, but how the hell do I know where it starts and finishes, right? Okay. This point here is a joiner between these two values. Yeah? One guy finishes at 3, the next person starts at 3. So I'm going to put 3 in here. 9 take away 2, 7. So I'm going to go up to 7, I'm going to put a dot, I go good on you, there's my graph. Positive gradient, 3, moves on. I'm going to go to this side of town and say negative a half. Right? Negative a half, put in here, you get negative 1.5 plus 2, which is positive a half. Here. Yeah? Because that's got a gradient of negative 3. So I've made both these look the same sort of steepness. This one starts at this point, this one starts or finishes at that point. And in between would be that graph. And if I'm good, that should have been 4. Because that's the one to see. Zigzag. Right? So when I said before, that's as hard as it gets, I lied. That's as hard as it gets.
Are you lying yet?
I don't know. I make up examples as I go along, so we just see. But no, the reality is about this one, because the x's have got different values, they're not going to cancel themselves in the middle, so I'm going to get an extra line. I'm always going to get a positive and negative guy, and I'm going to get a bit in the middle because one's a 2x and one's an x. They don't cancel each other. Questions with that? Right? It's the system. Plus, plus, minus, minus, and then worry about in between. Which one's positive, which one's negative? Add them. And understand what a hybrid function is. Okay? Understand what a hybrid function is. And actually, if I'm going to be formal, these should be just the thing here, boys. These thing here, that's where they're equal. Because when we picked the simple one, we would have had less than a value, more than a value, and we would have had equal to a value, yeah? When x equals a half, I have a problem. When x equals 3, I have a problem. So put the equal signs here. And that's why these dots are black. Because if they were both unopen, we should have had open dots. Yeah? But if I'm defined for this, and not defined, I don't care. As far as I'm looking at, it's a coloured in dot. Okay, and the last one, just quickly. I think most people are happy with this one. You draw a parabola, negative root 2, positive root 2, and negative 2 is what should have happened. Not 2, but negative and positive root 2. Right? So I drew a parabola without my sticks. I turned around and then I went, let's flip. And there's the sticks. Alright? So green is the finished product. So any parabola bit that comes below, turn it upside down. That's it. We'll touch on parabolas and stuff again, so I just threw one out there, something. If there was a big negative in front of it, you pick the whole thing up and put it down. Here, because that's going to mess me up here. So you're looking at the 2 points that make you 0. 0 for the first guy is negative a half. 0 for the second guy is 3. So they're my key points. I now look left of one, right of the other, and in between. There's your 3 zones. Oh, because this guy finished at 3 and started at 3. So if I put it in there or put it in here, I'd still get 7. It doesn't matter. 3 times 3, 9. Yep, you're just substituting into one of the functions.